Right, hello, this is sort of an ending really to the tutorials on trigonometry. This is the last one. We'll do another one just on a few questions. Now, what I'm not going to do is I'm not going to show you how these identities, well, you know what I mean, know about that in a minute, take place. How they occur, why. I'm just going to assume that you know that. I mean, I know it's dangerous to assume, but I think for purpose sake, for getting through the stuff, I think it's a lot easier if you just accept these. Again, if you're not sure about any of these, you can look them on. There are other videos online, but just for this one, I thought I'd make it a bit simpler for you. Assume that you already know this. You should be revising this stuff now. So the first thing we need to know, well, what is a trigonomic identity? Well, a trigonomic identity is just basically a couple of formulas. That means you can change, say, sine into tan, for example, and so sine into cos. Just change it. It's like changing the basis of logs, except changing the actual. Well, it's a sine and cos in front of it. So there's two here. Now this 5 to 10 minutes, you're just going through them, and then I'll apply them to some questions, and you can see why they're useful. I mean, just before I go, this is one of the most important parts of trigonometry. Apart from the quadrant rule, which is sort of the ending to the question, whereas the identity might be the start of the question. One of the most tougher questions on the exam. They might start with identity and then go on to the quadrant rule and figuring out in degrees and whatnot. So we've got sine. Now I'm just going to put sine theta, but they could label it as sine x over cos x. Over cos theta equals tan theta. So that's one there. I'll explain a bit about that in a minute. The other one is sine squared theta plus cos squared theta equals 1. So yeah, there are your two. I'll just put a little bracket around it because I'm going to leave them up for the rest of the tutorials. So don't need to worry about that. Just sort of move out of the way so you can actually see it. Yeah, I think you can see that alright. I'm not sure it'll come up on a computer screen, but anyway. So this here is when... Great. Pen's trying to have had enough already. That is just for... just when you've got... Well, it will come obvious if you need it or not. If there's another tan in the question, for example, and you've only got sine, cos, one of them two, and I'll do a few questions where that's apparent. This sine squared plus cos squared theta equals 1. You could sort of relate that to a circle if you needed to, because it looks a bit like a circle equation, that. With the radius of 1, obviously. So you could relate that somehow to that. But again, you could have a deviation of this. Now don't think, I'll just zoom in so you know which one I'm talking about. Don't think these two are like a set in stone. They can't be changed. They sort of can. Well, the actual formula sort of can, but the thing can't. So you've got sine squared theta plus cos squared theta. You can sort of rearrange that if you wanted. To get a quadratic trigonomic equation, you could have sine squared theta equals 1 take cos squared theta, or cos squared theta equals 1 take sine squared theta. Now that's just a change if you've got like sine squared theta plus cos theta plus 2 equals 0, for example. That's not a sufficient example. It probably doesn't work, but for that one you need to change the sine, and then you say between a certain angle and a certain angle, and you just use your knowledge of the quadrant rule to apply it to that. Again, don't worry if you don't understand that. I will do a few examples shortly. So that's one thing. Another thing you might need to know, I'll just put it up here. This is a bit less relevant, still relevant. So cos theta equals cos minus theta. And that's the same for sine. Now, just one other thing before I start. Obviously, you get the quadrant rule. You've got cast, anagram. So that's where each individual one is positive. So if you've got a sine that is negative, you'd go through the ones where sine is negative, for example. So it'd be good through cos and tan line in the quadrant, for example. That's just a few things before we start to get into the meaty bit of the questions. So I'll leave that up there, as I said, and we'll start. Just gonna pick a slightly tough one. See if we can pick one. Right, well, we'll do the first one. Says 2 sine x cos x plus cos squared x. These x's are the values of theta, just so you know that, equals 0. So it's starting to look like a quadratic equation already. And x, well, no, x is greater than 0 but less than 360, and they're both degrees, no less or equal to. Should have said that's right. So that's all the information we've been given in the question, and it's saying find the values of x or theta for values between 0 and positive 360. Now that's crucial for answering this question, and it will become apparent when you start to do the quadrant rule. But for now, what we've got is we've got sine and cos in there. Now we could use this one and try and get the sine into cos, but that's not going to be relevant just yet, because the first thing we need to do is we need to take out a common factor there, and you'll see why we do that in a minute. So if we take out a common factor of cos, so there's cos in this part, so that's 2 sine theta times cos plus cos theta squared, or cos x squared. So we take out cos from each part, so 2, so cos x, and we can write this as one whole equation now, 2 sine x or theta plus cos theta, cos x. Now you take out the power and you just take out the thing there. So this is a slightly easier one, that's why I've picked it to start off with. Hopefully you're following where we're going, so we took it out as a common factor. And obviously if that's going to equal 0, either cos x is going to equal 0, or 2 sine 2x plus cos x is going to equal 0. So we'll start with the easiest bit, we'll start with this bit. So cos x equals 0. So if we inverse sine that, both sides, you need to show your work. It's obvious, you know the answer is going to be 0. You can't just pluck a number out of thin air. Inverse cos of 0 equals 0, and therefore x equals 0. And I go, well, that's it. Yeah, it is between 0 and 360 degrees. Now the most common mistake students will make in this is we'll assume that, oh well, I've inversed cos the angle there. That's all I need to do. Whereas if you just step back, I'll step away from the screen, and you have a look at that. If that's like, I'm not sure how many marks they're exactly worth on average. I haven't worked it out, but they're going to be quite a large amount of marks for a question like that in the exam. If you've only wrote 3 lines, one of which is basic maths where you're just factorising the equation, I mean it may look very complicated with sine and cos in it and cos squared, but all you've done essentially is factorise it. So to inverse cos, that's quite simple. It's going to just, and there's a reason for this, that's because that angle given there is the angle essentially in the quadrant rule, but if you use 0 in the quadrant rule, you just get positive and negative 360. So what we have to do when it is 0, refer to the cos graph. Now I'm just going to go on a quick sketch of a cos graph here. if you forget the cos graph and the sine graph, it's very easy. Just put, because you've got positive 90, positive 180, positive 270, positive 360, and negative on the other side. And just simply type them values into your calculator and draw your given cos or sine graph. And when it's 0, that's when you'll get your answer. However, we don't need the negative side, because we're told in the question is between 0 and 360 is a positive number, so we don't need to worry about drawing the negative part and it just confuse you. So if we did that, the graph would end up looking something like this. So what we've got here is the two intercepts of 90 and 270. Just to prove it to yourself, if you don't understand how to plug them numbers, 90 and 270, type in your calculator and work out the individual values. Obviously this is going to be plus and negative 1, and we know when we inverse cos it's going to be 0, so that's going to be the degrees along that's going to be the value of the x along the axis there. And if you type in cos of 90, you're going to get 0, and cos of 270, you're going to get 0. Any other value, you get a positive number. If it's positive, you're putting in, but that's not going to get you 0. And we want something that equals 0. So you don't really need to do any calculations for this bit. So for x is 0, theta is going to be 90 degrees or 270 degrees. And that's why I changed it back from theta to x. So that's the first part done. I'm just going to give you a minute to copy that down, because I'm going to need to unfortunately rub that off just to give myself a bit more space in a minute for answering the second part of the question. So hopefully that's you've got it there. Now we've worked out this bit here. I'll leave the theta bit here just without the working at the bottom. So that part for theta is going to be 90 or 270. So we know on this side it's going to be 90, 270. But we don't know about this side. So we know this is where it gets a little bit more complicated. 2 sine x plus cos x equals 0. And this is where we start to bring, is it in this one? I think it is, yeah, just let me double check. Yeah, I've done this question before, I was just going through my notes. Now the bit we need to do now is we need to do our trigonometric identity. Now which one out of them do you think it's going to be? I've given you a hint there. We're going to use a trigonometric identity to solve that, purely because that's a sine and cos, and you can't add them two together. Well, you can, but we don't know what x is, so it is quite hard to do that. So which one of them two? And obviously it's not going to be that one at the top, because it's not really an identity, that's just more of a fact. So which one do you think it's going to be? Right, hopefully you've kind of worked it out. Well, the first thing we need to do before we do any of that, I'll sort of just give you a minute to try and figure it out before I wrote all over it. The first thing we need to do in this part is to rearrange it. So we've got 2 sine x equals, oh wait, do we need to do that first? No, we don't actually. So 2 sine, do we? No, we don't. So if that's over cos, we've divided the top one, by the way, to divide both by cos. So cos x would get this tan plus cos x over cos x, because you have to divide the whole. If you divide in one part of the equation, you have to divide all of it by cos x. So divide that by cos x, that equals 0. Now we could divide 0 by cos x, but that's just going to give us 0. So I'm not leaving out the end bit, but we wouldn't be factorising it if it didn't equal 0, because then we'd have to pull the adjacent number over into the equation, factorise it that way, and make it equal 0. So if it equals 0 at the start, that's good, but you need to make it equal. So as we know, sine theta over cos theta equals tan theta. So that's just sine x over cos x equals tan x. That's all we're doing. So that's 2 tan theta, or tan x, because it's a bit more easier to understand when we're trying to work out theta in this bit here, damn it. So 2 tan x plus cos x over cos x, which is going to give us 1. Irrespective of what x is, if we're dividing by the same thing as basic logic, it's going to be 1 equals 0. So rearrange this bit, so 2 tan x equals negative 1, and I'm not going to write each step you would do, so that means x equals the inverse tan of minus 1 over 2, so negative 0.5, and that's going to give us a x value of, actually I probably need to rub out that diagram on the left there, so just do that now. So tan inverse negative 0.5, but that gives us a value of negative 26 degrees. So I'll still write that down, so negative 26.56. Just rub off this bit here. I put theta is 19,270 at the top for the other equation, but just to give myself a bit of room, I've rubbed off that diagram. 19,270 degrees. So 19,270 is our given values that we already know from doing the previous part. Now we can't have a negative, so all we do is simply change it to a positive, because the cos theta equals of course inverse or negative theta, whatever you want to call it. So we can just change this value for x, because that's still degrees. That's not what we want. So that means x is positive 26 degrees. Now, as the inverse tan is negative, if we use our quadrant rule for explaining these diagrams, because we always, that's the value, this, when we inverse tan, what we get given there is the value bound by the line and the x-axis. It's not the value for this equation, it's a value bound by the x-axis. So that's the value bound by the x-axis, that's why we put x in there, to try and help you to figure that out. So if it's between if it's positive 26, we changed it. So it's going to be in the negative section where tan is negative, because we know tan, inverse tan is going to be negative. So if we use our cast rule, so CAST, that means cos is positive here, all of them positive here, sine is positive here, and tan is positive here. So we want where tan is negative, and tan is negative where the others are positive. So all of them includes tan being positive, so we can't use that. And tan positive section is obviously not going to work. So the only other two sections that we can use have to go like this. So you have to make sure it goes through the origin, which mine didn't. Now I hope you understand that it's logic really, that the other two are positive. So that's what we're going to put it through. Don't always assume that. It's just where it's negative, but you know. There you go. Got it? So it's bound by the x-axis. So we know theta is 26, so that's 26.56 degrees. And that's 26.56, or you could just write theta, but it really doesn't really matter. So there are your two angles there. And remember the quadrant, it goes positive round this way and negative round that way. So there are your two things. So there's our line. Now we're very close. If you know the quadrant rule by now, you can simply work the rest of that out, and we've done the trigonomic identities part of that question. So it's just a case of simplifying it and making it able to understand. Really, there's not much more to it than that. I mean, we've done the hard bit, as I said. So we know it's between 0 and positive 360, so we can't go the negative route. Sorry, just press on the camera. So we can't do the negative route, so we've got to do the positive. So we've got to go around in a clockwise direction, I think. Yeah. I'm just trying to think, my brain's funny. Great. Just trying to use a different colour, but obviously that didn't work. See if this red works. Yeah, so that's one way. You make sure you reach both sides of the line. So that's theta 1, theta 2. So theta 1 is 180 take away the angle, which is 25.5 0.56, and then that gives us the answer of 116. So theta 1 equals 116.56, and theta 2 equals 360 take 25.56, or 26.56, sorry, and that gets us an answer of 333.4. So everything I'm underlining in red is our answers for x. Just sort of make it brackets. So our value for x, or theta, given this equation is you've got the 90. I don't know if I point off screen there. So you've got your 90 there, the two values, and then the other two are at the bottom. And hopefully you've seen how we've worked that out from that equation there. Now I think I've got time for another one. Just see how we get on. Just making sure I don't kill myself. I'm sure you'd be disappointed for that. So there you go. That's the first part. Now we'll do just another question. This is one a bit more difficult, I think, personally. I mean, I've seen it a few times before. So we'll see how we go. Yeah. So I'm going to rub all this off. Okay, hopefully you've had enough time for me falling over to work that one out. Or write it down or whatever. Okay, you can just zoom back. Now you see why it's very it's not very difficult, but it's very easy to miss the x values when it's between 0 and 360, and you do it the negative way because it looks easier. You shouldn't do that. So this question here is a bit more advanced, I think. 2 sine squared theta take 2 equals 5 cos theta take 3. Oh, actually I should put x there. My mistake. X. So there are given values there. And this is why it's a bit harder, because it's sort of more an equation really than simply an answer. And it's for same sort of values. So x is greater or equal to 0 degrees and less or equal to 360 degrees. That's our given values for x. So how do we sort this one out? It looks quite complicated. First of all, because we've got sine and cos in there, and second of all, what we've actually got is an equation here. We need to make it equal to 0 and the rest of this equation here. So the first thing we can do here is we need to have trigonometric identities for this question, and it looks a bit more difficult. Instead of converting it, what we do is we need to, as I said, we need to make it equal to 0, because that looks more like a quadratic equation to me. So which we're going to use a second one, except we're not going to use it in that form because we're not adding them together, and also we've not got, although we'd end up taking them away, which we wouldn't equal 1. So what we need to do is rearrange that formula. I'm not going to write it down, but basically cos squared is going to be equal to 1 take sine squared theta. I just read that wrong. And then that'll enable us to create a quadratic equation from that and expand it, etc. So let's get ahead and do that. So as I said, the formula we're going to rearrange the second trigonometric identity to is cos squared theta equals 1 take sine squared theta. So put that in brackets because we're going to times it by 2 is sine squared theta is times by 2. We're going to rearrange it to sine squared theta equals 1 take cos squared theta. So cos I mean, I will write it in before I expand it, so you can see where we're going. Take cos squared theta or x. I'll put x. Close brackets, take 2. All I'm doing is rewriting out the rest of the equation now. 5 cos x, take 3. I'm not doing anything new at all with this so far. We expand this bracket, so 2, take 2 cos squared x, take 2 equals 5 cos x, take 3. If we sort that one out, make it equal to 0, pull all this side onto here, add it, take it away, etc. So 0 equals 2 cos squared x plus 5 cos x, and then we sort this rest of it out. 2 2's cancel out, so it's just take 3. If we can factorise that, you can use a quadratic formula, but I think factorising it's not too bad for this one. So 2 cos x and then cos x brackets, it's going to be plus 3 and take 2, I think. Plus 3 and take 1. Yeah, that's right. And I think that's factorised correctly. Just let me double check. So we've done it. Yeah. Plus what? Take 3. Yeah. Oh, plus is the wrong way around. Is it? Plus 5 cos. I'm not sure. Sorry. I know I'm sort of running out of time here. Just that should be right. So 2 cos squared, take 3, take 1 plus 6. Yeah, that's right. Right way around. It doesn't really. Yeah, it does. That's the right way around. So I've done it the wrong way around in my book. So 2 cos x take 1 equals 0. I'm just going to do 1. See how long I've got left. Just going to do 1, actually. Probably have the time to 1. So 2 cos x. So the cos inverse, I'm going to go quite quick here. So the cos inverse of positive half, so is going to be our x value. So our x value for one of them is going to equal, so cos inverse 0.5 is going to equal 60. So that's that's the value for x, is it? Is that right? Let's just see what I've done. I'm not sure I've done that right. So we get the same value. Sorry, just gonna pause the video. Sorry about that. So basically, what we're gonna do, I'm not gonna have time for this, but what we're gonna do is you would put that into one equation. So you put that into the quadrant thing, and then you would work it out in accordance to that at the top, and then do it again for the other value. So the cos x plus 3 equals 0, and then that would get you your answer. So I've gone through that very quick. I've not actually had time to finish it, but we'll see in the next video. So see you later.